of the square root of t. Find y prime. Go.
Prime over 1 plus
U prime over 1 plus u squared. Is that right? Okay, so first of all, I'm going to say that u is equal to what? T to the 1/2. So u prime would be 1/2 t to the negative 1/2. Clean that up before you plug it back in, which is 1 over 2 root t. Okay? So u prime is 1 over 2 root t over 1 plus u squared, which is the square root of u squared. Sorry, square root of t squared. Okay? So if I have a fraction on the top of a fraction, the denominator can come down to the bottom, right? So we get 1 over, this would be 2 root t on the bottom times the quantity, whatever's here, which is just 1 plus t. That's the best answer right there.
Yay.
I got it right.
Good. Who else got this? Equals arc secant of x over 2. Find g prime of x. Is that right?
Yes.
yes.
Let's see. U is what? X over 2 or 1/2 x. I'm going to just write it as 1/2 x.
Oh,
And then U prime is 1/2. Okay. So I get U prime is 1/2 over the absolute value of U, which is x over 2, and then times by the square root of U squared, which is x over 2, the whole thing squared, minus 1. Okay, let me give you another minute to take this one through. Can you get it to look like this? 2 over x times the square root of x squared minus 4. Okay? Go. X over 2, can I pull the 1/2 out of the absolute value? Is 1/2 always positive?
Yes.
So I know I can at least pull the 1/2 out. Okay, now inside of here, I have x over 2 squared, which is x squared over 4 minus 1, right? The
Oh.
1/2 and the 1 cancel, leave a 1 on top. So we've got
Melody Jones, contact the office.
1 over
Melody
absolute
Jones.
value of x. Now here I'd have to get a common denominator to combine these, so I'm going to times this by 4 over 4. So I get x squared minus 4 over 4. That whole thing is being square rooted. So I'm thinking right now that I probably need to leave the absolute value on the x, don't you think?
yeah.
Okay, on my final answer, so I have it written down on here. How do I get from here to here, though?
Square root of
Okay,
4.
I can square root these
Chuck
separately,
it on the top.
and then I can say 1 over absolute value of x times root 4 over root x squared minus 4. I can flip it over and multiply by the reciprocal of this. And I'm going to get 2 over absolute value of x times the square root of x squared minus 4. Now, if there was some kind of domain restriction, then we can take the x's at the absolute value away, but I don't see anything that will allow that. So I think we need the absolute value in there.
On the test, we have to simplify to that, or
If it's a multiple choice question,
Like,
it
say
might
if
be
it's-
simplified to this.
if it's like open response, are we
If
allowed
it's
to
open
leave it?
response, I would just clean this up a bit. And to Miss Nicole Deluxe.
Oh, we talked about it.
Okay. So I'm going to kind of shove the 13 out of the way because he's bugging me. What do I wish was right there?
9.
A plus 9. So how do I legally add a plus 9? Subtract a 9. Okay, so this part factors into x plus 3, the quantity squared. And then 13 minus 9 is 4. So this is equivalent to... Can I pull the 5 out? Would that be okay? This is bugging me also. So 1 over x plus 3 squared plus 4 dx. Don't forget the dx's. Okay? So what is this? It's arctangent. It's u squared plus a squared, right? So u is x plus 3. You're talking too much. Remember, if u is not literally x, you need to do a du just to be safe. So du is 1 dx, which I have on the inside, so I feel really good about that. And what is a? 2.
2.
It's the square root of that thing right there. So arctangent, what's the rule for arctangent?
1 over a
1 over a
arctan u over a
u over a
over a
plus c.
right? So I need to take my 5, don't forget your 5. 5 times 1 over a would be 1/2. Arctangent of u is x plus 3 over a, which is 2, plus c. Or 5 halves arctan. Why am I talking over people? X plus 3 over 2 plus c. You don't need to listen, you don't need to be taking up oxygen in the room. Okay? I don't mean in general, I just mean right now. Plus x to the 4th dx. It's an identity pretending to not be an identity, pretending to be an identity. So x
Oh.
dx.
do inception. We see right through that.
Okay? If I let u equal x squared, then what would du have to equal?
2x.
2x dx. So I actually am happy that there's an x up on top because that allows me to use what function? Or what identity? Is it arctangent?
Yes.
Yes. I got the wrong answer written down. Okay. So I need a 2 here. How do I happily place a 2 there? I need a 1/2 on the outside. So I've got 1/2 integral of du over, oh, what's a? 9. So can I just put a squared plus u squared? Would that be okay?
Yeah.
So 1/2 times, what's integral for tangent again?
1 over a.
1 over a, arctangent, u over a, plus c. So I got 1/2 times, 1 over a would be 1/9, arctangent of x squared over 9 plus c, which would give me 1/18 arctangent of x squared over 9 plus c. The square root of 4 minus x squared dx.
Oh no.
X over the square root of 4 minus x squared. Minus the integral of x dx over the square root of 4 minus x squared. Try splitting when you have 2 terms on top and just 1 on the bottom. Yes, ma'am?
Why can't you pull out the 2?
Because it's not a factor of the top. It's a term. You can't pull out a term.
So only if it's
If it was 2 times x, then you could pull out the 2. But since it's being subtracted, it's like trying to cancel common terms. You can't do that.
And when do you use division?
Integrals.
Separately.
Crier. Okay, do either one of these fit one of our formulas?
Yeah.
Which
X.
Doesn't this one fit one of our formulas?
Yeah, you can.
Yes, it does. 2 integral of dx over square root of 4 minus x squared. I can pull this 2 out because it's a factor at the top. It's not connected by plus or minus anything. So a could be 2 and u could be x, right? Okay. I'm going to kind of create a gigantic chart here. What about this one? Regular u substitution, very good. X dx over square root of 4 minus x squared. In this case, I'm going to let u equal what?
Equals
4 minus x squared.
And du would be negative
Negative
2x dx. So I need a negative 2 on the inside, which means I need what? Negative 1/2 on the outside. Okay, how about if I just do one at a time, because I'm going to start to confuse myself. I'm going to cover that up for a minute. Just buggy me. Okay, so 2 times the integral of du over the square root of a squared minus u squared would be 2 times the integral of what? Arc sine of u over a. I'll add the plus c at the end. If you want to add plus c right now, that's okay. So that's 2 arc sine of x over 2 plus c. Okay. Oh my goodness. Okay, so I've got minus a negative 1/2, which is plus 1/2.
Wait, on that first one, can't you just like put it up at the top and like put -1 and then integrate it? Oh, maybe I'm integrating it. Never mind.
No. That's a no.
Okay.
Okay, so this is, too much talking, du over the square root of u. So can I write this? Oh.
Du.
This is really u to the negative 1/2 du, right? It's over the square root of u. Just going to cover that up. This is like the watery. Negative 1/2, we get u to the 1/2 over 1/2 plus c. Then what?
1/2 cancel out.
1/2 cancel, and so I'm basically adding u to the 1/2, which is plus, can I back substitute now?
Yes.
4 minus x squared to the 1/2 or square root plus c, but I don't need 2 plus c's. So 2 arc sine of x over 2 plus 4 minus x squared to the 1/2 plus c would be your final answer. Anybody? Square root of 4 minus x squared, y equals 0, x equals 0, and x equals 1. Find the area bounded by those 4 curves, dx. Is this a rule?
Yeah.
Which rule is it? Is it arc sine?
Yes.
A squared minus u squared, so a is 2 and u is x. Okay. So I'm going to go 0 to 1 of 1 over the square root of a squared minus... Now, I get that some of you don't need to put the a and the u in. You could just go straight to the integral. That's okay. I just have to do it in steps or else I get confused. So if you're a little slow, I'm just saying, what am I saying? I get that you can move there. That's okay. I just like to take it nice and slow.
Do we use points on the AP
No,
test?
as long as you're showing good stuff, you don't necessarily have to do that.
Are you going to change the boundaries or not?
Well,
They'll
they
be the
wouldn't
exact
change
same.
because 0, u, and x are the same thing.
But
I can't change them. They don't change. Why would I
Well, don't
change
you
them?
set them to like A and B?
They won't change because u is equal to x. Put 1 in, it's going to come out as a 1 formula. Arc sine of u over a
0 to 1. 0 to 1.
from 0 to 1. So it's the arc sine of x over 2 from 0 to 1. Okay, so I've got arc sine of 1/2 minus arc sine of 0. Okay, what's the arc sine of 1/2? Pi 6. What's the arc sine of 0? It's 0. So pi 6 minus 0 is pi 6.